Hi, everyone. Welcome to the SLOconf monthly meetup. I'm very excited to be joined here by Adriana Villela from Lightstep. Adriana has been a SLOconf speaker as well a few months ago, so I'm very excited to have Adriana come here today and talk about observability and anti-patterns. Before I let Adriana take over, I just wanted to give a short intro of the agenda today. So right now we have, and by the way, this is set for Pacific time, so you can probably see the hour and wonder what that is. But we have the welcome right now, and then Adriana is going to take over and present. I'm very excited about this talk, by the way. I know it's a brilliant one, so I can't wait for everyone to hear it. And then we're going to have breakout rooms. I highly suggest everyone to stay for that, because that's going to be the time we get to socialize and get to know each other and talk with each other about whether that's anti-patterns or something else. That's kind of the social section of this meetup. After that, we're going to have a dedicated Q&A. You are, by the way, allowed to ask questions to Adriana while she's talking if you use the chat. So whatever question you have, drop that in the chat. When the talk's over, we can go through them, or we can wait to the Q&A session. We'll see how we feel. And then we can have a discussion if anyone's up for that. And then it's time to go enjoy the SLOconf chat. Yeah, before Adriana takes over, again, thank you so much, Adriana, for doing this today. Very excited to have Adriana part of this meetup. Adriana is a podcaster, she's a tech blogger. She's done so many brilliant things. I followed her journey since I started working in tech myself. So I'm very, very impressed by your amazing expertise, Adriana. And today, like I said, Adriana will be talking about observability anti-patterns. So whenever you're ready, feel free to take over.
Hello, everyone, and welcome to Observability Anti-Patterns. I'm super happy to have you join me here today. But before we dive in, let me tell you a little bit about myself. My name is Adriana Villela, and I love solving hard problems, whether it's part of my day job as a senior developer advocate or on a rock wall, which is where you'll find me when I'm not at work. I am a CNCF ambassador, newly minted as of this year. I'm a second-year HashiCorp ambassador, tech blogger, co-host of the On Call Me Maybe podcast, and I am super happy to be speaking here today to you about a subject that is super near and dear to my heart. Now, as I stand here before all of you, I cannot help on reflecting on just how complex technology has gotten in the last couple of decades. I mean, when I graduated from university in 2001, having internet access on your mobile phone was barely a thing. Shout out to flip phones, hey-o. The Google search engine had been around for only 3 years, and we were just starting to move from those 3.5-inch diskettes to USB sticks for portable personal storage. Monolithic apps were a thing, Java was a hot language, and cloud, what cloud? Now, software these days is orders of magnitude more complex than software that was out there when I graduated university all those years ago. And now troubleshooting software in production is even more complex than it used to be before. I mean, before it was like already hard and annoying, but now we've gotten to the point where we've got so many systems interacting with each other. We've got microservices applications where services are interacting with each other in often very unpredictable ways. And so it's very hard to understand what is going on in our systems as a result of that. Now, fortunately, we've got observability to help us out with that. Now, observability is all the rage these days, which I'm super, super stoked about, but I'm also a little bit biased because, you know, have you ever been at a place that claimed to be all in on observability, only for you to realize that you're not exactly following observability practices? The thing is, I've been in the space long enough to witness my fair share of anti-patterns, and today I'll be calling these out in the hopes that you can bring these learnings back to your respective organizations, whether you're an executive or an individual contributor. And I'm going to speak about not one, not two, but 6 anti-patterns. Now, before I do that, I do want to take a brief little detour to set the stage to define a few key terms, just to make sure that we're speaking the same language. And I know you want to get to all the meaty bits, but I promise that this detour will help with our narrative. So let's get started. First of all, let's define observability. Now, there are many definitions of observability out there, and for the purposes of this talk, I'm going to go with the observability definition that I love, which is observability, or OLLY, or O11Y for short, lets us understand a system from the outside by letting us ask questions without knowing the inner workings of a system. Now, what does that mean? It basically means that even though you don't understand all the nitty-gritty underlying business logic of that system, the system emits enough information for you to follow the breadcrumbs to answer the question, why is this happening? All right, so we get observability, but you can't have observability if your system doesn't emit information. But how do you get that information? Well, it can come from OpenTelemetry. Now, OpenTelemetry, or OTel for short, is an open source, vendor-neutral framework for instrumenting, generating, collecting, and exporting telemetry data. Now, I love OTel because it has a backing of all of the major observability vendors, basically making it the de facto standard for instrumenting your applications. Next, we can't talk about our observability landscape without talking about service level indicators, or SLIs. Now, SLIs are a thing that you measure, and more specifically, it's a two-dimensional metric that answers the question, what should I be measuring? And, SLIs include number of good events over total number of events, i.e. success rate, or number of requests completed successfully in 100 milliseconds over total number of requests. And this is important because we need SLIs for SLOs. See, they do come into the picture after all. So SLOs, or service level objectives, are informed by SLIs, which is basically just a fancy way of saying that SLIs are the building blocks of SLOs. Now, SLOs help answer the question, what is the reliability goal of the service? So if we went back to one of our previous SLIs where we're talking about our success rate, i.e. our number of good events over total number of events, our SLO would say something like, we would like a target of 95% success rate over a 28-day rolling period. All right, so we have the basics of our terminology. So now we can get into the anti-patterns, or as I like to call them, high crimes against observability. So high crime number one, undervaluing the trace. Now, before I get into this one, I do want to call out the fact that at the end of the day, traces, metrics, logs are all structured events, and that they each convey different things and serve different purposes, but they are events at their core. That being said, I'm going to call out the fact that far too many organizations put way too much emphasis on metrics and logs while either completely disregarding or downplaying traces. Sure, I mean, metrics and logs are useful, but they are not enough. Now, metrics are events that give us information about things like CPU levels and the amount of time that it takes to complete a transaction, but they provide aggregate information, so you cannot drill down into them to understand what's going on with your system. Now, logs provide us with useful point-in-time information, but they don't tell us the big picture of what's going on. They tell us about a thing that happened at a particular point in time. So, but with respect to what? And the other thing is, typically logs come in an unstructured format, which means that they are super, super nasty to sift through. Now, at the end of the day, neither metrics nor logs give you enough context to understand what's happening with your system at a high level. So the biggest crime against observability is committed when metrics and logs are treated as the main actors of your observability story, when in fact, they take more of a supporting role. And spoiler alert, traces are the true stars of the show. So how do we fix this? Well, we take a trace first approach. So as you may have gathered, traces give you that end-to-end system-wide view. So they show you not only what's going on within services, but also across services. Now, that's not to say that I'm saying goodbye to metrics and logs. No, not at all. What we are saying, however, is that we want to make sure that, first of all, if you're going to use logs as part of to help tell part of the story, make sure that the logs are structured so that they are easy to parse. And also make sure that you make those logs useful by making them part of the overall story by correlating them to the traces, because You might see a thing that's happening at a particular point in time, but you have no idea what it relates to. What other things happened before you got to that point that is being logged in your log message? So that's why correlating them to the traces makes sense. Similarly, you want to make your metrics more useful by correlating them to the traces where possible. So now we're getting a full picture of what's happening, because now we've got our metrics and logs funneling additional information into our traces. Okay, high crime number 2, the Wall O dashboards. And this one is a bit of nails on chalkboard for me, because I once worked at this place where my boss thought that their production woes would be solved by dashboarding all the things. His favorite thing to say was how he set up a wall of dashboards when he worked at his previous company and it helped them so much. And the thing is that just because something worked for you 10 to 15 years ago when systems were a lot simpler and observability as it exists now wasn't really a thing, doesn't mean that we should continue doing things that same old way. It is time to get with the times and rethink that Wall O dashboards. Now, many organizations still work under the assumption that what worked for troubleshooting 5, 10, or even 20 years ago would still work well for troubleshooting today's systems. Back then, organizations relied on setting up dashboards on huge wall-mounted monitors to keep an eye on things. And when something broke, engineers would run those queries against these dashboards to figure out why the thing was breaking. And every new problem encountered was then put up on the dashboard as yet another thing to keep an eye on. But when you think about it, that's pretty bananas, because every single new problem, you're going to schlep it onto a dashboard? I mean, it makes zero sense. What would make, at the end of the day, it ends up being too many things to keep an eye on. And realistically speaking, there's no way that you can possibly predict all the things that are going to go wrong in a system. Now, so this was okay when we were dealing with less complex systems and those known knowns, but these days we're working with exponentially more complex systems that behave in unpredictable ways. So we can't rely on traditional monitoring methods for troubleshooting. So how do we fix this? Well, instead of using metrics from dashboards, instead of relying on dashboards, we say, no, we are not going to be dashboarding all the things. Let's instead use SLO-based alerting. So as you may recall from earlier, SLOs help us answer the question, what is the reliability goal of the service? So basically, if we switch from our traditional dashboards to SLO-based alerts, it basically means that if your SLO is breached, your system notifies your on-call engineers, and the alert tells your engineers that, hey, something is wrong. And secondly, because you have correlated those lovely metrics to your traces, as per our previous anti-pattern, or this is our pattern, not anti-pattern, correlating metrics to traces. Because you've done that correlation, now you've finally made your SLOs actionable, because now you're saying, okay, I have a problem. This is where I should start looking. So rather than looking for a needle in a haystack, now you actually have a starting point so you can follow those breadcrumbs to answer the question, why is this happening? All right, next anti-pattern is high crime number 3, not instrumenting your own code. Now, when organizations get into the observability space and start instrumenting their own code, they often fall into this trap of getting an external team to instrument code for application teams. So the team that's tasked with this often tends to be the observability team or the SRE team, for example. And this might happen because management recognizes that instrumentation is important, but they don't have time to pull developers off of new feature work to go back and instrument existing code, or they can't afford the ramp-up time needed to learn how to instrument code. And either way, this is a terrible, terrible idea. Now, I worked at an organization where I ran an observability practices team, and our mission was to establish and disseminate observability across the organization. Now, part of that included us teaching teams how to instrument their code with OpenTelemetry. But unfortunately, while leadership was all in on OpenTelemetry, they wanted my engineers to instrument code that they weren't working on. Now, what is the problem with this? The problem is that the engineers being asked to instrument the code aren't the ones who are writing the application code. So as a result, they don't know what information is important for troubleshooting. Imagine that you're writing code and you're troubleshooting your own code. Now, as you're troubleshooting, you have a pretty good inkling of the things that you need in order to understand why a particular bug is occurring. So for example, oh, you know what? I have no idea what's going on in this variable. Maybe I need a little print statement there. And you know that you need the print statement there because you're writing the code and you're troubleshooting it. Now, imagine asking me to instrument your code. Well, I have no idea. I don't work on this code. I have no idea what's important to you. So that's the equivalent of asking someone else to comment your code for you or write your unit test for you. Now, I understand that instrumenting existing code can be extremely overwhelming because, as I mentioned earlier, there is a learning curve and there's probably a lot of code to instrument, because when you look at it, now all of a sudden, if you're instrumenting new code, you're basically ending up with new technical debt that you didn't even know that you had, which is super freaking scary. But there is a path to make this a little bit better. First of all, you have to recognize the fact that you may need to put some features on hold in order to instrument your code, especially if your system is consistently experiencing reliability issues. I mean, if your house is on fire, are you going to continue constructing the house, or are you going to try to put out the fire? The other thing that you need to keep in mind is to identify critical, frequently used services and maybe work on instrumenting those. And of course, another good way to instrument your code is to any homegrown frameworks or libraries that you have. Instrument those, because chances are a lot of your code is probably going to be touching those. So that's a nice quick win. And then finally, you will want to instrument new code as you write it so that you don't have to go back and instrument it later, because then you're just adding more technical debt to your already big pile of technical debt. And this practice is known as observability-driven development. Now, don't take my word for it. I will leave it up to the amazing Liz Fong-Jones to leave some parting words on this topic. And this is a snippet of our conversation that we had with her on the On Call Me Maybe podcast.
You're a full grown-up software engineer, write your own damn tests, right? Like, so write your own damn comments, write your own damn observability annotations, right? Like, this is what will help you understand your code later. Someone else writing it for you achieves like very little of the value.
Words of wisdom from Liz. All right, high crime number 4, belief that observability and observability tooling are the same thing. Now, y'all remember when DevOps started to become a thing and everyone and their uncle's goats started buying CI/CD tools and declared that they were DevOps? We are kind of seeing the same trend with observability. There's this belief out there that because you're using OpenTelemetry and you're sending observability data back to an observability backend does not make your system observable. You have to ask yourself the following questions. Are you sending the right information, and is it enough information? At the end of the day, you need to know if you need to ask yourself whether or not your system is emitting enough information that you need so you can follow the breadcrumbs to answer the question, why is this happening? And if you're neither emitting enough information nor sending the right information, you probably don't have observability. So if you decide to bring observability into your organization, you need to think about it in terms of practices and not in terms of the tooling. So ask yourself, are you instrumenting your code properly so that you have enough information to troubleshoot when systems arise? Is it enough information? Is it the right information? You need to make sure that you're treating your traces as first-class citizens, like we learned in anti-pattern number 1. We need to keep an eye on the health of our systems after we release code to production. We cannot just do hit and run deployments. Just because the code technically deployed successfully to production doesn't mean that it was a successful deployment. You have to see your code out in the wild. There is no better indicator of how successful your code is than by putting it in the hands of the most unpredictable creature ever, which is the human being with a computer, because humans can do weird things to our software that we never imagined possible. So don't deploy and walk away. to keep an eye on your code to see how it is doing in the wild, to make sure that it is behaving as expected. And finally, making sure that you are creating meaningful alerts based on your service level objectives. High crime number 5, observability theater. Now, we've seen the scene play out before. We have companies going all in on agile transformations and DevOps transformations or digital transformations. And these are very well-intentioned initiatives, and I think they add a great deal of value to our organizations. But ultimately, a lot of these types of transformations end up failing either due to lack of buy-in or lack of knowledge around how to execute the transformation successfully. So a lot of these organizations, a lot of leadership do things for show, which makes it look like they're implementing these transformations when in fact it's all theater, and they all get mad when it fails and try to hire consultants to fix things up, which kind of sucks. So like DevOps and Agile, observability is a paradigm shift. And like DevOps and Agile, it is very easy to fall into the same traps. So at the end of the day, it means that you have to forget about, in order to have a successful observability practice, you have to forget about the things that you did 5, 10, 15 years ago. Otherwise, you end up with these well-intentioned organizations standing up an observability practice that just turns out to be monitoring in disguise with the same old, relying on dashboards and logs to troubleshoot and lacking that end-to-end system visibility. So how do we fix this? Well, you need that convergence of buy-in from both the top and the bottom. And it's achieved through education, evangelism, case studies. If you're an executive, open your mind to the paradigm shift of observability. If you've been around the block on these types of big initiatives before, as I have, you know that change can't and won't happen without buy-in from the executive level and from individual contributors alike. So be part of the positive change. I'll give you an example. So there's this person that I worked with recently as part of the Open Telemetry and User Working Group, and she gave a really great we did a really great Q&A session where she was talking about how her organization has this great observability culture because executives are fully bought in to the whole observability paradigm shift. And that includes the giving teams the directive that application teams are responsible for instrumenting their own code. So it means that her team, which is the observability team, these development teams can't go to her team and ask them to instrument the code because no matter how much they whine, because this is a directive from the executives, they know that they are stuck instrumenting their own code and they can't rely on another team to instrument that code. But of course, on the other side, you have to make sure that the folks who are executing on the observability, those who are instrumenting the code, are the ones and who are maintaining observability related infrastructure are the ones who are also bought into this whole observability idea. Because sure, you can have mandating, you can have it mandated from the top, but if the folks who are supposed to be doing the work don't believe in it, well, it's still going to fail. So if you're in a position of an individual contributor and you're trying to really convince folks of the value of observability, I'd say nag, and nag some more, and POC, and nag and POC some more. Show your boss and your coworkers how awesome observability is and how it can make life easier for everyone. And finally, high crime number 6, the last high crime against observability, not treating observability as a team sport. Now, observability is one of those things that has to be looked at holistically. And at the end of the day, reliability cannot happen without observability. It's not a thing that's separate from SRE. It is a part of SRE. And the thing is that it's not the sole responsibility of any one team or individual because everybody has an important part to play. So what do I mean by this? So as we learned in anti-pattern number 3, observability-driven development, we want to encourage developers to keep observability in mind throughout the coding process by instrumenting their code using open telemetry. So this promotes a proactive approach to observability. Now, after an application has been handed over to the QA team, Now that team has an application that has been instrumented. Well, that's awesome, because the QA team, as they're running their tests, they can use observability to their advantage to basically file more detailed bug reports. So they can go back to developers and say, hey, I found this bug and I think the root cause is blah. Why? Because they have that observability data that can prove that. And if they do find a bug and they don't know why it's broken, they can also go to the development team and say, something's broken, I don't know why, which means that you haven't instrumented your code sufficiently. So this keeps developers on their toes, ensuring that they are emitting enough information so that you can follow the breadcrumbs to answer the question, why is this happening? But we can take it one step further with QA, which is we're bothering to instrument our code. We're taking this trace-based approach. Let's leverage those traces to create what's known as trace-based tests. So a trace-based test basically uses our traces to create automated assertions. So we have integration tests that leverage our traces. And there's some really great tools out there that already do that, including trace test, there's Malabi, and there is also, oh shoot, I am blanking out. Helios is the other tool that does that. Now, by requiring code instrumentation as a quality gate, our developers are encouraged to emit the necessary information for better observability, making it easier for SREs to troubleshoot production issues to gain insight into system performance. Now, our SREs can leverage that telemetry data to create service level objectives and to create alerts based on these SLOs. So when an SLO is breached, they know that there's a problem. And because the SLO is telemetry based and those metrics that drive the SLOs are tied to the traces, they have that information to follow the breadcrumbs to answer the question, why is this happening? Now, SREs are also responsible for configuring things like the OpenTelemetry collector to ingest application instrumentation written by developers and to collect infrastructure telemetry as well. So there's multiple different ways in which SREs are part of this observability story. So by basically expanding the reaches of observability beyond SRE, so we're including the developers, we're including the QAs, it's not just the SREs, we end up with much more reliable systems and a much better understanding of how they work and how they're being used. So, like all worthwhile things, achieving observability greatness isn't an overnight thing, but if you keep the following things in mind, they will help guide you on your observability journey. First, we make traces first-class citizens. We say bye-bye to the Wallow dashboards and hello to those SLO-based alerts. We encourage developers to instrument their own code. We treat observability as a set of practices supported by tools. Sort your practices out before reaching out for the shiny new thing. Promise you it'll be much better. Just say no to observability theater. And finally, treat observability as a team sport. So there you have it, all 6 observability anti-patterns. Now that is a lot to take in, and whenever I write my blog posts or give a talk, I like to reward my audience's patience with cute pictures of my pet rats. I am a rat person. This is my pet rat, Phoebe. She is named after the Friends character, and she's almost 2 years old, which makes her a little grandma rat, and she really likes to cuddle into little things, little holes. Thank you so much for sticking around. Be sure to check out the various resources that I've posted on here. I have a blog post on Medium on observability anti-patterns that inspired this talk. You can check out my whole series on unpacking observability on Medium, which is basically my exploration of trying to understand observability from when I took on the role of managing an observability practices team a couple of years ago to now. There are also some really great books to check out, including Cloud Native Observability with OpenTelemetry, Implementing Service Level Objectives by Alex Hidalgo, and of course, check out OpenTelemetry. There are always really amazing ways that you can contribute to OpenTelemetry, and of course, using it to instrument your code. final note, these lovely capybara images that you've seen throughout this presentation were not generated by me because I do not have that kind of artistic talent. However, I make an excellent prompt engineer. So I would like to thank Dolly, all hail our evil AI overlords, for helping to create these lovely AI generated images. Feel free to scan this QR code to follow the On Call Me Maybe podcast and give us a listen. This will take you to our various socials and whatnot. And finally, if you would like to stay in touch, scan this QR code to follow me on, I'm on most of the socials, including Blue Sky. So please feel free to follow, reach out. I would love to continue the conversation. Until next time, peace, love, and code.
Amazing. Wow. That was an amazing talk. A round of applause, a quiet one, for Adriana. I absolutely loved it.